Welcome to Aptitude for Placements, and my name is Ranjit. I have conducted this aptitude training program at various engineering colleges all over India, and every year thousands of students get placed by attending this aptitude training program. Here you will find all the questions that are commonly encountered in most of the aptitude tests. These are the questions that keep on repeating in many of these tests. So just familiarize yourself with all these questions and you will have a clear advantage when you attempt your actual placement test. Let's start. In a 400-meter race, A can give B a start of 20 meters. So we'll just represent that data here. Now they are running a 400-meter race. Now assume that this is the starting point. Now A can give B a start of 20 meters. So A will allow B to run for 20 meters. Altogether 400 meters. So remaining distance is 380 meters. And when B does this remaining 380 meters, A will do the full 400 and they will finish simultaneously. Also, it is mentioned A can give C a start of 39 meters so that all three of them finish simultaneously. In the same race, A will allow C to run for 39 meters. Altogether, it's a 400-meter race. C has already done 39 meters. So, remaining distance is 361 meters. And when C does this remaining 361 meters, in that much time, A will do the full 400 and they will finish simultaneously. Now the question is, in an 80-meter race, how much start in meters can B give C? So we'll compare the speeds of B and C. Now when A does this 400 meters, in that much time, B will do 380 and C will do 361. So in a fixed time, when B does this 380, in that much time C will do 361. So we'll just simplify this. Now 380 is equal to 19 into 20 and 361 is 19 into 19. I'll just cancel out 19 and 19. So if you compare the speeds of B and C, they are the ratio 380 is to 361. That is same as 20 is to 19. So if you compare B and C, they are in the ratio 20 is to 19. Now the question is, in an 80-meter race, so we will find out the distance covered by C when B does 80 meters. That is, if you multiply both values by 4, 20 into 4, this will become 80. And this is 19 into 4, this will be 76. So you can see when B does 80 meters, C will do only 76 meters. So if they have to finish simultaneously, B should initially allow C to run for 4 meters. And when C does the remaining 76 meters, in that much time, B will do the full 80 and they will finish simultaneously. So in an 80-meter race, how much start in meters can B give C? That is, B can allow C to run for 4 meters. So option B, 4 meters. In a 1-kilometer race, A can give B a start of 40 meters. So assume that this is the starting point. Now it's a 1-kilometer race and A allows B to run for 40 meters. Now remaining distance is 960 meters because altogether 1 kilometer or 1000 meters. So after 40, remaining distance is 960 meters. And when B does this remaining 960 meters, in that much time, A will do the full 1 kilometer or 1000 meters and they will finish simultaneously. Also, A can give C a start of 160 meters so that all three of them finish simultaneously. So A will initially allow C to run for 160 meters. Now altogether it's a 1 kilometer race. So remaining distance is 840 meters. And so you can see that when C does this remaining 840 meters, in that much time, A will do the full 1 kilometer or 1000 meters and all three of them will finish simultaneously. The question is, in an 8 kilometers race, how much start in meters can B give C? Now we'll compare the distances covered by B and C. When A does 1 kilometer or 1000 meters, in that much time, B will do 960 meters and C will do 840 meters. So in a fixed time, when B does 960 meters, in that much time C will do 840. So we'll just simplify this. I'll cancel out the zeros. Now 96 is 12 into 8 and 84 is 12 into 7. I'll cancel out the 12s. So if you compare B and C, their speeds are in the ratio 960 is to 840, that is same as 8 is to 7. So if you compare B and C, their speeds are in the ratio 8 is to 7. So when B does 8 meters, C will do 7 meters. Similarly, when B does 80, C will do 70. When B does 8000, C will do 7000. Now it is an 8 kilometer race, and how much start in meters can B give C? So you can see that B should initially allow C to run for 1000 meters. And when C does the remaining 7000 meters, in that much time, B will do the full 8000 and both of them will finish simultaneously. So B should allow C to run for initially for 1000 meters. Then they will finish simultaneously. So in an 8 kilometer race, how much start in meters can B give C? B can give C 1000 meters. So option B, 1000. In a 1 kilometer race, A can give B a start of 200 meters. So we'll just represent that data. So you have A and B here. This is starting point. Now they are running a 1 kilometer race. A can give B a start of 200 meters. So A can allow B to run initially for 200 meters. Now it's a 1 kilometer race, so remaining distance is 800 meters. And when B does the remaining 800 meters, in this much time, A will do the full 1 kilometer or 1000 meters and they will finish at the same time or simultaneously. Also, A can give C a start of 300 meters so that all three of them finish simultaneously. In the same race, A can allow C to run for 300 meters. Now remaining distance is 700 meters. And when C does the 700 meters, A will do the full 1000 meters and they will finish simultaneously. Now the question is, in a 1 kilometer race, how much start in meters can B give C so that they finish simultaneously? Now when A does the full 1000 meters, in that much time, B will do 800 meters and C will do 700 meters. So if you compare the speeds of B and C, in the time that B does this 800 meters, in that much time C will do 700 meters. So we'll compare the speeds of B and C. I'll cancel out the zeros. So if you compare the speeds of B and C, they are in the ratio 8 is to 7. Now the question is, in a 1 kilometer race, how much start in meters can B give C? So when B does 8 meters, C will do 7 meters. Now we need to find out the distance traveled by C when B does 1000 meters. 1000 meters is same as 1 kilometer. Now 8 into 125 is 1000. 8 has been multiplied by 125. So 7 should also be multiplied by 125. 7 into 125, you will get it as 875. So when B does 1000 meters, C will do 875 meters. So if they have to finish simultaneously, B should initially allow C to run for 125 meters. And when C runs the remaining 875 meters, in that much time, B will do the full 1000 and they'll finish simultaneously. So basically, B should allow C to run for 125 meters. So in a 1 kilometer race, how much start in meters can B give C so that they finish simultaneously? That is, B should allow C to run for 125 meters. So option B, 125. To calculate a relative velocity, we need to have two objects. That is, two objects should be there. How much the distance between them, how much it changes per hour. Or it can be calculated in meters per second. the distance between two objects, how much it changes per hour. So we'll take some examples. Let us say you have a point here. Now there are two people A and B. They are both at this point. Now person A is moving in this direction at A kilometers per hour. So A is moving in this direction, A speed is A kilometers per hour, and B is moving in this direction and his speed is B kilometers per hour. Initially they are both here. So what is the relative velocity between A and B? So initially they are both here, so distance between them is 0. A speed is A kilometers per hour, so in 1 hour A will do A kilometers. And B speed is B kilometers per hour, so in 1 hour B will do B. Initially they are both here, so distance is 0. So after 1 hour the distance will now become A plus B. A has done A kilometers, B has done B kilometers. So after 1 hour distance has now become A plus B. That is why relative velocity in this case is A plus B kilometers per hour. They are getting separated by A plus B kilometers per hour, or generally distance between them is changing by A plus B kilometers every hour. Now let us look at one more case. There are 2 points like this. Person A is here, person B is here. Now initial distance between them is x kilometers. Person A is moving in this direction at A kilometers per hour, and person B is moving in this direction at B kilometers per hour. So now you can see that they are getting closer. In this case, what is the relative velocity between A and B? Initial distance between them is x kilometers. Now A speed is A kilometers per hour, so in 1 hour A will do A kilometers. B speed is B kilometers per hour, so in 1 hour B will do B kilometers. So after 1 hour the distance will become x minus A plus B. So you can see that initially it was x, after 1 hour it has become x minus A plus B. That is, they have got closer by A plus B kilometers per hour. So in this case also relative velocity is always A plus B. That is, in this case they are getting separated by A plus B kilometers every hour. In this case they are getting closer by A plus B kilometers every hour. Initially it is x, after 1 hour it has become x minus A plus B. They have got closer by A plus B kilometers. Now it doesn't matter if they are getting closer or if they are getting separated. In both the cases relative velocity is always A plus B, because distance between them changes by A plus B kilometers per hour. Now let us look at one more case. You have a point here. A and B are both here at this point. Person A is moving in this direction at A kilometers per hour. B also in the same direction at B kilometers per hour. In this case, what is the relative velocity between A and B? Initially they are both here, so distance between them is 0. A in 1 hour will do A kilometers, B will do B kilometers. So after 1 hour distance will now be A minus B kilometers. So in this case relative velocity is A minus B kilometers per hour. So I can generalize like this. Two people, they are moving in the same direction. Then relative velocity will be the difference of their speeds. It will be A minus B. They are moving in opposite directions. They are getting further apart or they are getting closer. Whenever they are moving in opposite directions, relative velocity is always A plus B. Same direction, A minus B. Two runners A and B are at the same point on a circular track. They start at the same time and run in opposite directions with speeds 7 meters per second and 5 meters per second respectively. So we'll just represent all this data here. So you have a circular track like this. Now assume that this is the starting point. So two runners A and B are at the same point. So A and B are both here. Now they are running in opposite directions. So I'll just assume that A is running in this direction and B is running in this direction. Now A speed is 7 meters per second and B speed is 5 meters per second. Now you can see that they are moving in opposite directions. If the circumference of this circular track is 1440 meters, after how many seconds will they meet? So circumference or one full round is 1440 meters. Now assume that they will meet at some point here. This is starting point, and when they meet here, you can see that to meet here they have to do one full round. That is, A has to do this much distance, B has to do this much. When will they meet? When they complete one full round, they will meet. Now time required is distance by speed gives you time. Now to meet they have to do one full round. So one full round is same as 1440. Distance is 1440 by speed. You can see that they are moving in opposite directions. They are moving towards each other. So relative velocity will be the sum of their speeds. That will be 7 plus 5. This will be the relative velocity. So their relative velocity will be 7 plus 5, 12. So distance by speed gives you time. 1440, 144 is 12 into 12 and the 0. So I'll write it as into 10. Divided by 7 plus 5 gives you 12. 12 and 12 cancels out. Thus 12 into 10 gives you 120. So 120 seconds. In this much time they will meet. So after how many seconds will they meet? They will meet in 120 seconds. So option B, 120. Two runners A and B are at the same point on a circular track. So we have a circular track like this. Assume that this is starting point. Now A and B are at the same point on a circular track. They start at the same time and run in opposite directions with speeds 4 meters per second and 3 meters per second respectively. So we will assume that A is running in this direction. A speed is 4 meters per second and B is moving in this direction. His speed is 3 meters per second. If the circumference of the circular track is 3500 meters, after how many seconds will they meet? So circumference or one full round is 3500 meters. So you can see that this is the starting point and they are moving towards each other. We will assume that they will meet at some point here. Now when they meet here, what will be the time required for them to meet? So time required is given as distance by speed gives you time. This is starting point here. Now when they meet here, you can see that if you add up the distances traveled by both A and B, it will be one full round. When will they meet? When they have completed one full round among themselves, they will meet. So to meet, they have to do one full round. So distance of one full round is 3500 meters. So distance is 3500 and you can see that they are moving towards each other, or they are moving in opposite directions, or they are moving towards each other. So relative velocity will be the sum of their speeds. That is 4 plus 3, 7. So distance by speed gives you time. Speed or relative velocity will be 4 plus 3, 7. So we'll just calculate. That is 3500 by 4 plus 3, 7. 7 divides 5 times. 5 into 100 gives you 500. So altogether time required is 500 seconds. So after how many seconds will they meet? They will meet in 500 seconds. That is option D. Let me briefly explain how to prepare for your aptitude test. First of all, you need to familiarize yourself with all the questions that have been worked out here. These are the questions that keep on repeating in many of the aptitude tests. After that, you need to attempt practice tests. According to me, you need to attempt at least 10 practice tests before your actual placement test. Here, I will be giving you 10 practice tests, and these practice tests will be ideal for you to improve your test scores. The 10 practice tests are available at a cost of only rupees 200. So all that you need to do is make a payment of rupees 200 either through Google Pay or through PhonePe or through Paytm, and you will receive the 10 practice tests. The details of the payment comes next.